So we're going to jump back into Module 14, which is object-oriented programming. And I covered a lot of information last time, so if your head is swimming a little bit, that's okay. We're going to add a few more concepts to that today, and then I'm going to spend a fairly large amount of time going over an assignment that or project that is a parallel to what you're going to be doing. So I'm not going to do the assignment in front of you, but I'm going to do a project that has all the same pieces to it. I'm going to get it on video and post that to the class website, hopefully later today. And then as you work on assignment 14, you should be able to follow along that video and kind of develop the equivalent pieces of assignment 14. So it should help you quite a bit in terms of getting through your first object-oriented program. So really quickly, before we jump into new stuff, I want to review a couple of things that we went over. Remember, a class is a blueprint for something. We use that blueprint to create instances or objects of that class. And that class, what a class does, is it groups data and abilities, or things that we do to that data, into one package. And that allows us quite a bit of power and flexibility when it comes to programming. So the things that we have in that class are data, which are properties, which are actually just variables that belong to that class. And we also have methods, which are functions that belong to that class. So a property, of course, looks like this. We've got a class called CLCar, and in it we have a property called int_wheels. And that's an integer, and it's only available in that car. Now, if you remember, each instance of that car can have a different value for int_wheels. They all have int_wheels as a property, but we can change that for each instance of a car. So if we wanted to create a car called my motorcycle, we could give it 2 wheels if we wanted to. Methods, similarly, are functions that are developed inside or defined inside a class, like this one here. Start car is a very simple function or method that belongs to the class CLCar. And again, each method is executed on a per instance basis. So if I have 2 different car instances and I run the method for start car on one of them, I only ran it for that instance. It's like building a car using a blueprint, which is the class. If I build 5 cars from that blueprint, they're all the same car, they all have the same ability, they all start out the same when they roll off the assembly line. But I can paint those cars different colors. Some of those cars I can drive, some I can park, some end up in Jay Leno's garage or whatever. So we have all of these different cars that all have the same place of origin or the same blueprint. They have the same basic abilities, but they may end up with differences, different properties. So when we look at that in code, right, we have our car class here that we worked on last time. We've got wheels and we've got a Boolean running. I added here a Boolean available. If it's a rental car company, if it's available to rent, true or false. And remember, we have the initialization method, which gets run automatically every time you create an instance of this class. And we have the string method, which is what is returned when you print that class. So it becomes the sort of the identifier for that class. And in this case, we have a color and a model with mileage. We also have methods called start car, another method called drive car that checks to see if the car is running before adding the mileage to it. And then we have a rent out, which changes the available setting to false. So if the car is rented, then it's no longer available to be rented. You can see here that we also use the technique of creating an empty list that serves as a container for our cars now. So our entire fleet of cars, we have 3 right now. This Toyota that's silver, a Ford that's green. And then we have one where we use the default properties, which are set here. So it's a Toyota that's white. And now I can go through and I can address, what I'm addressing is the green Ford right here. But I rented it out, and then I started it, and then I drove it. And then what I used is a for loop to go through my entire list of cars. And if the car is available, meaning it's not currently rented out, so if available is true, then we print that list of cars that are still available. So if I run this code just as it is, you can see here, I started the car, I drove the car, it has 100 miles now. And then here's my list of the other 2 cars that I have in my fleet that are available. The other one, of course, was rented out. So this is a short, very linear program that uses a class. And it uses a lot of the things that we talked about in terms of class. And then hopefully you had some time to play around with the virtual pet here. And for the most part, I mean, this mostly works right now. But what it doesn't have is the menu option filled out here to feed the pet or play with the pet. The feed pet one is this one, and it works fine. So if I run this program, you can see I can adopt a pet. What's the pet's name? Jake. Adopted a new pet and named them Jake. Check on my pets. There's Jake's hunger and boredom score. So if I want to feed Jake, I can select Jake. You fed Jake. And if I check on Jake now, you can see his hunger is 10, his boredom is 5. So far Jake is doing good. All I can do is feed Jake now. So if I keep feeding him, obviously his hunger is going to get better and better. And for some reason, it's not taking any points away here. But, I don't have the take turn getting triggered anywhere. So that's a problem. So if I wanted to, after each thing, if I wanted to, I would just have to trigger the take turn here at the bottom of that loop to make sure that turn happens, and then Jake's going to get progressively more bored and hungry till he runs away. So that is some code. Those are the code that we've sort of looked through so far.